Hello, I'm Denis Makori, a teacher of maths and physics in Boqol. And today we are going to cover maths. For now, we are going to learn maths, which is Form 1. And we are going to start with Chapter 9, which is square and square roots. In the previous class, we covered on squares, whereby we did some examples on how to find the squares and square roots of numbers, fractions, and decimal numbers generally. We also did some examples on how to find the squares of numbers using tables, whereby we learned on how to use tables and how to find squares from tables. Generally, we said yesterday or the day before, when we want to find the squares of numbers, the tables do not give us the actual squares of numbers, but we are given the approximate values of the square of numbers. So the tables just give us the approximate value to 4 figures of numbers to 4 figures, while you can just find the square of numbers, the actual square of numbers using multiplication. But in case of tables, we say the square of numbers are given to approximate value. We also said when you are given a number which is more than 4 digits, you have to round off the number to 4 digits so that you can find the square of a number. You cannot find a square of a number using tables if the number is more than 4 digits. Now, I think yesterday was the first time you came across the 4 figures, and we say don't be worried of the other topics or the other chapters of the 4 figures. For now, let us concentrate on squares and square roots. We said a table is made of 4 columns, 3 main columns. A table has 3 main columns, whereby we have the first column is for x. In the case of squares, we read the first column is for x, whereby the values of x range from 1.0, we have 1.1, 1.2, continuously up to 9.9. This is the first column. The second column, we have values starting from 0, 1, 2, up to 9. Also, we have the last column where the values range from 1, 2, up to 9. And in this case, in this column, each column is added add. And I remember yesterday we said this column is known as the difference column. Difference column. And we use the values in the difference column to find the square of numbers with 4 digits. The 4th digit in any given number with 4 digits, the 4th digit, we find the value from the difference column, then we add the values in the first and the second column. Now, today we want to cover on how to find the square roots of numbers. Our main topic today is square roots. So we start, our topic today is square roots. Want to see on how to find the square root of numbers. When finding the square root of numbers, there are 2 ways you can find the square root of numbers. The square root of numbers is found by a factorization method. You can use factorization method and use of tables. These are the 2 ways you can find the square root of any given number, by factorization method and by use of tables. So we start by square roots. Square roots by factorization method. Square roots by factorization method. Want to see how to find the square root of numbers by factorization method? Remember, square root is the opposite of square. Yesterday we said the square of 5 squared is 25. 5 squared is 25. We also said x squared is just x times x, which is x squared. 20 squared is 20 times 20, which is 400. 20 squared is 20 times 20, which is 400. So the square root of a number, for example, the square root of 25 is the number which you square to find 25, which is 5. So that means the square root of 25 is 5, because when you find the square of 5, the answer is 25. So doing the opposite of what you have done, which is the square root of the given number, is 5. The square root of x squared is x, because when you square x, you find x squared. And the square root of 400 is 20, because when you square 20, the answer is 400. Now, let us see on how to find the square root of numbers by factorization method. When using factorization method to find the square root of numbers, first thing what you have to do is to write the number in prime factors. And that's what we covered in the third topic, which is factors. By now, I know you know how to write a number in prime factors. For example, how can we write 816 in prime factors? Yes, how can we write 816 in prime factors? Now, there are two ways you can use. You can write this number in prime factors. You can use a table or you can use a factor tree. I want us to use a table. So what you do, use a table, we write 816. The least factor which is can divide 816 is 2, which is 408. We have 2, 204, 2, 102, 2, 5, 1, 3, 17, and 17, 1. So writing this number in factor form is 816 is 2 times 2 times 2 times 2 times 3 times 17. Whereby in this case, since we have 2 appears 4 times, we can write 2 in index form or in power form and say the answer is 2 power 4 times 3 times 17. And that's how we write a number in factor form. So when you want to find a square root of a number by factorization method, what you have to do first of all, write the number in prime factorization method. After writing the number in prime factorization method, then you can find the square. Now, how can we write 324 in factor method? Can you try that and tell me the answer? Yes, 324 in factor method. Yes, Mohammed? Correct. This is 2 times 2 times 3 times 3 times 3 times 3. Whereby since 2 appears twice, it's 2 power 2 times 3 power 4. 2 power 2 times 3 power 4. Last example, we have 425. And want to try that and write that number in prime factors? 425. Yes, Abdurrahman? Yes, that's 5 times 5 times 17. In this case, it's not a must that you have to start with 2. What you are supposed to do is to start with the least factor, which you can divide by 425, which is 5 times 5 times 17, and the answer is 5 squared times 17. Since 5 appears 2, the answer is 5 squared times 17. Now, when finding the square root of a number using factorization method, after writing the number in prime factors, what you have to do is to group the number into a pair. In a pair, you pick one number. In a pair of given numbers, you just pick one number. Now, let us do this example. Use factorization method. Use factorization method. Use factorization to evaluate. Use factorization method to evaluate the square root of 1764. We want to use factor method so that we can find the square root of 1764. So what you do, first of all, write 1764 in factor method. We can use a factor 3. In this case, I used a table, but now in this example, let me use a factor 3. We have 1764, start with 2, 882, 2, 441. We have 2. No, we have 3, because 2 is not divisible by 441, so we start with 3, 147. Again, we divide this by 3, we have 49. Divide this by 7, 7. Divide this by 7, 1. So 764 in factor method, it's 2 times 2 times 3 times 3 times 7 times 7. After writing that number in factor method, in a pair of 2, in this case, this is a pair, you pick 1. So the answer is 2, pick 1 times 3, pick 1 times 7. So these are a pair of 2 numbers, I pick 1. These are a pair of 2 numbers, you pick 1. And these are a pair of 2 numbers, you pick 1. And 2 times 3 times 7 is what? The answer is 42. So the square root of 1764 is 42 using factor method. Another example, we have a number such as 5184 using factorization method. 5184. Now I want to write this number in factor method, in prime factors. I want to find the square root of 5184. Can you try and write that number in factor method or in prime factors? Write 5164 in prime factors. Yes, Mohammed, we have 2 times 2 times 2 times 2 times 2 times 2. It's 1, 2, 3, 4, 5, 6 times 3 times 3 times 3 times 3. That's when you write that number in factor method. So we have said this in a group of a pair of numbers, or in a pair, or in a group of 2 numbers, you pick 1. This is 2. This group pick 1, and this group you pick 1. Also pick 1. In this case you pick 1. So this is 2 power 3 times 3 squared, whereby the answer is 72. That means the square root of 5184 is 72. Or after writing the number in factor method, you can write the number in power form. This is 2. 2 appears 6 times. 2 appears 6 times. So you can say 5184 in factor method, it's 2 power 6 times 3 squared. 2 power 6 times 3 squared. I remember in the previous class we said when you are finding the square of a number by multiplication method, you can find the square of a number by, after writing the number in factor method, you can find the square of a number by multiplying the powers by 2. By multiplying the powers by 2. I'm sorry, this is 3 power 4. Correct. Thank you for the correction. This was 2 power 6 times 3 power 4 because 3 appears 4 times, not 3 power 2. So it's 2 power 6 times 3 power 4. So in this case, I've said, yesterday we said, when finding the square of a number by multiplication method, you can write the number in factor method. After writing the number in factor method, you multiply the powers by 2. If we have forgotten, we can do an example. For example, I need to find the square of, maybe I want to find the square of 72 squared. I want to find the square of this. What I do is to write 72 in prime factors. What's the answer? 72 in prime factors. The answer is 2 power 3 times 3 power 2. When you write that number in prime factors, it's 2 power 3 times 3 power 2. So you want to find the square of this. So if I want to find the square of this using multiplication method or by factor method, you can write this 2 power 3 times 2 times 3 power 2 times 2. That's when you are finding the square of this number by factor method, which gives you 2 power 6 times 3 power 4. 2 power 6 times 3 power 4. So that you can find 2 power 6 is 64 and 3 power 4 is 81, whereby the answer is 5,104. That's when you are finding the square of a number. But now, when finding the square root of a number, we have said it's the opposite of the square root. Square root of a number is the opposite of a square. So in this case, remember we multiply the powers by 2. So in this case, for us to find the square root, what you do is to divide the powers by 2, whereby we have 2 power 6 times 3 power 4. If I want to find the square root, I just divide the powers by 2. 6 divided by 2 times 3 power 4 divided by 2. Whereby in this case, the answer is going to be 2 power 3 times 3 squared, and the answer is 72. So when finding the square root of a number, by this, you just divide the power by 2. You divide a given power by 2. What if we want to find the square root of 4,356 by factor method? Can you try this? 4,356 square root by factor method. Can you try that? 4,356 in factor method. Yes, today's. The answer is 66, correct? But how did you find 66? First of all, you wrote this number in factor method. It's 2 power 2 times 3 squared times 11 squared. Or you can say it's just 2 times 2 times 3 times 3 times 11 times 11. So in this pair, pick 1, 2. This pair, pick 1, 3, and this pair you pick 1, 11. So that the answer is 66. The square root of 4,356 is 66. Last example, you can also try this. 76,176, the square root. 76,176. Find the square root of that using factor method. Don't use your calculator and start shouting your answer. Use factor method to find the square root of that. 276,176. 76,176, correct? So first of all, let us write this number in factor method. 76,176. We have, it's 2 times 2 times 2 times 2 times 3 times 3 times what? 23 times 23. I've said there are 2 ways you can write this. You can just say it's 2 power 4 times 3 squared times 23 squared. So finding the square root, you divide the power by 2, divide this by 2, divide this by 2, you divide this by 2, whereby this gives you 2 squared times 3 times 23. 2 squared is 4, 4 times 3 is 12, 12 times 23, 276. So the square root of that is 276. So you can say the square root of 76176 is 276. Or you can just group this into 2, you pick 1, group this into 2, pick 1, and you pick 1. So you are going to have 2 times 2 times 3 times 23, whereby the answer is 276, which is the square root of 76,176. Now, I think these examples are enough. Now, let us see on how to find the square root of numbers in tables. But before we do that, just write this statement. You write this statement. In general, you note, in general, to find the square root of a number, find the square root of a number, find the square root of a number by a factorization method. Find the square root of a number by a factorization method. Pair the prime factors. You pair the prime factors. Pair the prime factors into two identical numbers. Into two identical numbers. Into two identical numbers. After pairing the factors into two identical numbers, for every pair, comma, pick only one number, then obtain the product. Pick only one number, then pick only one number, then obtain the product. That's what you are supposed to do when generally finding the square root of numbers by a factorization method. Write the number in prime factors. After writing the number in prime factors, you group the number into two identical numbers, and for every pair of numbers, pick only number, then obtain the product. Now, Mohammed is asking whether you can find the square root of a number by factorization method of a number which is not a perfect square. You cannot obtain the square root of a number which is not a perfect square by a factorization method. For example, there is no way you can obtain the square root of 40. Remember, 40 is not a perfect square. And you know a perfect square is a number which has an exact square root. For example, perfect squares between 1 and 9 is 1, 4, 9. Those are only perfect squares between 1 and 10. So there is no way you can find the square root of 40 by a factorization method. Because when you write 40 in prime factors, it's 2 times 2 times 2 times 5. So in this case, there is no way you can group these into identical numbers. We only have 2 appears 3 times. So we have no exact number of 2. You cannot group this into pair. So you only find the square root of numbers by a factorization method of perfect squares. The rest, we use staples to find the square root. So this is what you are supposed to do generally. So if you are given a number, write the number in factor method, group the prime factors into two identical numbers, then for every pair, pick only one number for you to find the square root. After picking one number, find the product of those numbers. Now, how do we find square root from tuples? Square root from tuples. We are through with square roots by factorization method. Now, we want to see on how to find the square root from tuples. Square root from tuples. Square root from tuples. Now, I remember yesterday we said for numbers between 0 and yesterday we said this, for numbers between 1.00 and 9.99, the squares of those numbers can be read directly from tuples. Any number ranging between 1.00 to 9.999, the squares of these numbers are read directly from tuples. I remember also said for a number which is less than 1, numbers for example 0.0 something, 0.19, 0.0089, for numbers less than 1 and for numbers greater than 10, squares of those numbers are obtained from tables by first of all writing the number in standard form. After writing the number in standard form, you can find the square root of that given number, the square of that given number. So same case, when you are finding the square root of numbers from tables, this is what we did yesterday on how to find the square of numbers between 1.00 and 9.99. Just redirected that number, the square of that number from the given table. But now, for numbers less than 1 and greater than 10, write the number in standard form, then you find the square. We say this, when finding the square, please don't forget to find the square of the power of 10. You have to find the square of the power of 10. Now, tables of squares are used in a similar way to tables of squares. That's the first statement. Tables of squares, the tables of square roots are used, tables of square roots are used in a similar way. Tables of square roots are used in a similar way to tables of squares. So if you can open your 4 figures on page, squares was on page 21. This is the 6th edition for figures. If you open your 4 figures on page 21, and make sure you open where we have square roots. Don't open wherever we have squares or another reciprocals or whichever it is. Look at your 4 figure and make sure you open where we have square roots. Square roots are starting from page 21 to page 24. So we are going to concentrate on page 21 to page 24. That's where we are going to concentrate. So open your 4 figures, page 21 to page 24. That's where we are going to concentrate. Now, same case, the tables of squares has 3 columns. So the tables of square roots also have 3 columns. We have the difference tables, we have where we have x from 1.0 to 99. That's the difference between tables of squares and square roots. And we also have the second column, and we have the third column where is the difference column, where we have the add column. So in tables of squares, the similar way we are using the tables of squares is the same way we are going to use the tables of square roots. So square roots of numbers, square roots of numbers, square roots of numbers, square roots of numbers from 1.00 to 99.99 are given in tables, and can be read directly The squares of numbers from 1.00 to 99.99. Now that's the difference between squares and square roots. Squares was just from 1.0 to 9.999. Square roots is from 1.000 to 99.99. Any number ranging between 1.00 to 99.99, you just read the square root of that numbers directly from the square roots of tables. Now, this does not mean when you have a number less than 1 or a number greater than 100, you cannot read the square root, or you cannot find the square root of that number from the table. You can find the square root of that number after writing the number in standard form, or you can also write the number in the form of a times 10 power n, then you can find the square root of that given number. But now, let us concentrate on numbers between 1.00 and 99.99. So let us look at some examples on how to find the square root of these numbers between 1.00 and 99.9. Now, find the square root of each of the following numbers. Find the square root of each of the following numbers. Of each of the following numbers. The first number is 40. The first number, we want to find the square root of 40 using tables. Square root of 40 using tables. Now, the same way we are using the tables of squares, this is what you do. And just draw an illustration of the tables of square roots. We have x, which starts from 1.0. We have 1.1, 1.1, up to the last value. In this case, it's 99, not 9.9, no, but it's 99. So that's why we have said we are going to concentrate from page 21 to page 24. That's x. Also, we have the second column, we have 0, 1, 2, continuously up to 9, that's the second column. The last column is the difference column, add and add. Also we have 1, 2, 3, up to 9. That's what we have. That's an illustration of what we have in your four figures. Now, you can see in the tables of squares, if you look at those tables of squares, in the first column of 0, from 1.1, the first digit is 1.0. Just extend this. We have 1.000. The next number is 1.0488. We also have 1.0954. So, starting with the second value with 1, this is where we have 1. It says where we have 1, 2, then now continuously up to 9. In this case, we have 0050. Just writing the values of 1 on the second column. We have 0536, 0536. This is 1.2. We also have 100. Now, you obviously know that the square root of 1 is 1. The square root of 4 is 2. The square root of 1. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. Continuously, square root of 25 is 5. So that's why you can see in the first column of x, when you start with 1.0 up to where we have 4.0, all these values start with 1 point something. We have 1, we have 1. Up to where we have 4.0, that's where we start with 2.000. Up to where we have 4.0, that's where we have 2.000. Next, we have from 4.0, all these numbers between 4.0 up to where we have 9.0. The first digit is 3.0000. So this means for numbers between 4 and 9, their squares range from 2 to 3. So what this means, this first digit, which is 2, applies in all other digits between the numbers given in the second column. So if we want to find n square root of a number between 4 and 9, the first digit should start with what? 2. all these numbers in this table, your first digit. Remember, in this case, we have a decimal number. We have the odd number part and a decimal part. So the odd number part should start with 2. Again, from 9 up to where we have 16, that's where we start with 4.00. Up to where we have 25, we start with 5.00. So this is what it means. All numbers between 16 and 25, their square root start with 4. A number which is more than 25 to 36, the square root starts with 5. So if I want to find the square root of 40, what I do, look at where we have 40 on the x column. And we have said 40 lies between 1.000 and 99.99. So I can just read the square root of 40 directly from my table. So can you look at where we have 40? And when you are only given one number, this means it's just 40.0. So what you are supposed to do is just find the square root of 40.0. So looking at your 4 figures, look at where we have 40.0. What's the square root of that number? The answer is 6.3246. The square root of 40.0 is 6.3246. What I've done, or what you have done, I know, you have just look at where we have x, move down to x squared to where we have 40. Look at 40.0, and I think the answer is 6.3246. So just read the square root directly from the table, which is 6.3246. I want to find the square root of 5.38. Square root of 5.38. How can I find the square root of 5.38? Second example, it's 5.38. So what you do at your x values, look at where we have 5.3. On your x, on your 4 figures, look at where we have 5.3. So first of all, you pick the first digit on the x column, which is 2. The first digit is 2. So it means the square root of this should start with 2, because on the 0 column, the first digit or the whole number part is 2. Next we have 3, 5.3, the first digit is 2. 8, we have 3195. So that means the square root of 5.38 is 2.3195. This 2 is the first digit on the x column, where we have 5. This is where we have 5. 5.3. So 5.3, the first digit is 2.3022. 2.3022. So that's why I've said these first 2 applies in all other these numbers in the other columns of the 4 figures. So in this case, the square root is 2.3195. Another example we want to see on how to find the square root of 6.142. Square root of 6.142. So on your x columns, look at where we have 6.14. 6.14, look at that value. The first digit starts with 2. So at 6.14, yesterday we said this, when we have 4 digits, first of all, you look for the first 3 digits. First of all, on the x column, look for 6.1. And look at 4, the answer is 2.6.14. Look at that value. 6.14 is 2.4779. 4779. When you go to the difference column on that same horizontal line, go to the difference column where we have 4, where we have 2, we have 4. So in the difference column we have 4, and we said you add it to the last digits. So when you add this, we have 3, 8, 7, 4, 2. So the square root of 6.142, it's 2.4783. 2.4783. And that's the square root of 6.142. What's the square root of 89.72? 89.72. How do we find the square root of that number, 89.72? What you do, go to your x column, find 89. On your x column, you find where we have 89. Then you go to where we have 0.7. 0.7 we have 4710, and the first digit is 9. So it's 9.4710, 9.4710. Then the difference column, we look for the value which intersects with 2. Value which is intersecting with 2 is what? 11, correct. So what you do, add this to 11. The answer is 9.4721. And that's how you find the square root of that number, which is greater than 89.72. Sometimes you can be given a number which is more than 4 digits. And what you are supposed to do is just to round off that number to 4 digits. After rounding off that number to 4 digits, you can find the square root of that given number. For example, let us say you want to find the square root of 98.7993. 98.7993. If I want to find the square root of this number, I round off this number to 4 digits. Round off the number to 4 digits. So you count the number of digits we have 1, 2, 3, 4. Look at this digit, it's more than 5. So it increases the preceding digit by 1. So when you increase this by 1, it becomes 10. Carry 1, the answer is 98.8. So this is the same as finding the square root of 98.8. Same case, in this case, you are given just the approximate values. We are not given the actual values. So what's the square root of 98.8? Using your tables, I know it must start with 9, because 98 lies between 81 and 100. The square root of 81 is 9, the square root of 100 is 10. So this means the square root of 98 should start with 9 points. What's the square root of 98.8? The answer is 9.9398. 9.9398. So what we have said, before you write the square root of a given number, first of all, consider the first digit on the 0 column, the first whole number digits. And that number applies in all the other numbers. And after finding that, the square root of the other numbers, you can first find them using you can just write the first digit, and inside the first digit is 9, then you can write the rest of the digits. That's how you find the square root of the other number. Finally, can you tell me what's the square root of this? Square root of 50.8915. What's the square root of that? As we have said, that's correct. First of all, you have to write this number to 4 digits, which is the square root of 50.89. And using your tables, on 50.8 we have 7 point what? 50.8 we have 7.1274, and 7.1274. That's where we have, that's the value where we have 50.8, and the difference column at 9 we have 63. So you add this gives you 73317. So the square root of 50.8, the approximate value is 7.1337. And if you are told to use a table to find the square root of a given number, use a table to find the square root of that given number. So lastly, the last thing we are going to see is on how to find the square root of numbers which are less than 1. For now, I want us to do, we can find square root of numbers which are greater than 100. But now we want to see on how to find the square root of numbers which are less than 1. Square root of numbers less than 1. Now I can use this. We have seen how to use this. Let's find on how to use the square root of numbers less than 1. Or after finding the square root of numbers less than 1, you can also find the square root of numbers greater than 100. So the square root of numbers less than 1 and greater than 100, square root of numbers less than 1 and greater than 100. So this is what you do when you want to find the square root of these numbers. A, write the number in the form of A times 10 power n. Write the number in the form of A times 10 power n, where 1.000 is less than or equal to A, which is less than 100. That means the value of A must range between 1.00 and 99.9, and n is an even integer. N should be an even integer. Write the number in the form of A times 10 power n, where A ranges between 1.00 and less than 100. That means it should range between 1.00 and 99.99, and n is an even integer. The reason as to why n must be an even integer, we have said when finding the square root of a number, by factorization method, we said you can divide the power by 2. So if n is not an even integer, you cannot divide that integer by 2. So you have to write n to be an even integer. So I want to just do some 2 examples on numbers less than 1. Then we find the square root of the other numbers in the next class. So evaluate the following. Evaluate the square root of 0.146. 0.146. So I've said, first of all, write the number in the form of A times 10 power n, and n must be an even integer. So 0.146 is the same as, this is 14.6 times 10 power negative 2. I can write this number as 1.46 times 10 power negative 1, and because negative 1 is not an even integer, this is an odd integer. So this one, I cannot find the square root of this. So what I do, I write the number so that 14.6 lies between 1.00 and is less than 100, and n is an even integer. So what I do now, for me to find the square root, I find the square root of 14.6 using depots, then I find the square root of 10 power negative 2. The square root of 14.6 can be read from your tables. What's the answer? 14.6. The answer is 3.821. 3.821 times. Now, the square root of 10 power negative 2, you can write 10 power negative 2 as a fraction. 10 power negative 2 is the same as 1 over 100, whereby the square root of 1 over 100 it's 1 over 10. So it's 3.821 times 1 over 10, because the square root of 10 power negative 2 is 1 over 10. Or you can just divide 10 power negative 2, divide the power by 2. And that's why the power must be an even integer. When you divide the power by 2, it becomes 10 power negative 1. 10 power negative 1 is the same as 1 over 10. So it's 3.821 times 1 over 10, or times 10 power negative 1. Also write 10 power negative 1. And the answer is 0.3821. This one is same as 0.3821. Or you can just leave your answer in standard form. This is your answer in standard form. You can either write your answer as in standard form or in normal form. One more example on the same. We have 0.001952. 0.001952. The last example, we have 0.001952. Write this number in the form of A times 10 power n. Remember, n must be an even integer. This is 1, 2, 3, 4. Becomes 19.52 times 10 power negative 4. Point is A must lie between 1.00 and it should be less than 100. So find the square root of this. You also find the square root of this. The square root of 19.52 using depots is 4.4159. 4159. Then you add the difference column. We have in 2 intersects with 23. So you add 23. This becomes 4.4182. So this is 4.4182 times 10 power negative 4. It's 10 power negative 2. Let's divide just the power by 2, which is 4.4182 times 1 over 100. And the answer is 0.044182. When you write that number in normal form, or in standard form, it's 4.4182 times 10 power negative 2. Those are just 2 examples. So now we find the square root of numbers which are less than 1. We are going to do more examples next time on how to find the square root of numbers using tables which are greater than 100 and less than 1. Now, that's the end of our lesson. We have covered on how to find the square root of numbers by factorization method and by use of tables for numbers which are between 1.00 and 99.99. Now, next time we are going to do more examples on how to find the square root of numbers which are greater than 10 and less than 1, more examples on the same. Let us meet next time. Thank you.